Hello. Let's talk about building microservices on the cloud in this session. After you have completed this session, you should understand what are microservices, what to avoid when building microservices, what are the elements of microservices architecture, and why is DevOps so critical while building and deploying microservices. We will see the capabilities offered by Bluemix for developing microservices and also look at case studies of microservices implemented in Bluemix. Microservices is an architectural style in which large, complex software applications are composed of one or more services. Microservices can be deployed independently of one another and are loosely coupled. You need to be able to deploy a single microservice on its own. This loose coupling enables frequent and rapid deployments, getting much needed features and capabilities to our consumers. Each of these microservices focuses on completing one task only and does that one task really well. Microservices can be developed in any programming language. They communicate with each other using language-neutral APIs such as REST, as well as other mechanisms which we will discuss later. Microservices have a bounded context. What do we mean by bounded context is that a particular microservice does not know anything about the underlying implementation of other microservices surrounding it. If for whatever reason a microservice needs to know anything about another microservice, you definitely don't have a bounded context. Microservices need to focus on a unit of work, and as such, they are small. There are no fixed rules on how small a microservice must be. Our focus is on keeping the interface small. And also we want to keep in mind the latency. What that means is when you're decomposing a system into smaller autonomous microservices, we are increasing the number of calls made across network boundaries for the services to handle a request. These calls can be either service-to-service calls or service-to-persistent component calls. Those additional calls can slow down the operating speed of the system, therefore running performance tests to identify the sources of any latency in any of these calls is important. You can use Bluemix monitoring and analytics service for this purpose. Also, microservices should be caching aggressively. You can also add concurrency, especially around service aggregation. Since using the correct tool for the correct job is important, microservices need to be built using the programming language and technology that makes the most sense for the task at hand. Microservices are composed together to form a complex application, and they do not need to be written using the same programming language. In some cases, Java might be the correct language. In others, it might be Python or Node.js. A microservice needs to be treated like an application or product. It should have its own source code management repository and its own delivery pipeline for builds and deployment. A monolithic application is an application where all of the logic runs in a single app server. Typical monolithic applications are large and built by multiple teams requiring careful orchestration of deployment for every change. We also consider applications monolithic if while there are multiple API services providing the business logic, but the entire presentation layer is still a single large web app. In both these cases, microservice architecture can provide a good alternative. As you see in this table, Microservice architecture has multiple code bases. It is easier to maintain. We can scale bottlenecked services without having to scale the entire application. Each microservice can be deployed individually with minimal downtime and can be developed in different programming languages as required. Also, let's compare SOA with microservice architecture. Both of these are service architectures as they deal with distributed systems of services communicating over the network. However, the practical results are a little different because the focus of SOA is on reusability and discovery, whereas the focus of microservices is on replacing a single monolithic application with a system that is easier to manage and incrementally evolve. SOA attempts to put these services forward to anybody who wants to use them. Microservices, on the other hand, are created with a much more focused and limited goal in mind, which is acting as a part of a single distributed system. This distributed system is often created by breaking down a large monolithic application, and the intent is that a collection of microservices continue to work together as a single application. Typically, we don't have an ambition to serve multiple systems at the same time. Also, unlike with SOA, microservices often exist implicitly. They are not discovered at runtime and do not require mediation. They are well known to the consumers and therefore do not require service description. This does not mean that some kind of discovery is never present. Some sophisticated microservice systems might apply degrees of service discovery to make them more flexible and more robust. The main point is that such an architectural pattern is not required. A microservice system where all microservices are aware of each other use relatively simple configuration files and can be still an effective solution. Teams can discover what microservices are available for them to use at development time using either a catalog, a registry, or API management tools. In any case, SOA and microservice architecture share many principles, patterns, and a programming model. When beginning new applications, do not demand that microservices be included in them. Microservices attempt to solve problems of scale. When you're starting, your application is tiny. It takes a certain amount of time and effort by a growing number of developers to even approach monolith and therefore the microservice territory. It is important, though, to be aware of when you are approaching monolith status and react before that happens. Microservices cause an explosion of moving parts. Therefore, it's not a good idea to attempt to implement microservices without serious deployment and monitoring automation. You should be able to push a button and get your app deployed. In fact, committing code should get your app deployed through the commit hooks that trigger the delivery pipelines. Microservices often introduce multiple databases, message brokers, data caches, and similar services that all need to be maintained, clustered, and kept in top shape. It really helps if your first attempt of microservices is free from such concerns. A PaaS such as IBM Bluemix or Cloud Foundry enables you to be functional faster and with less headaches than with an infrastructure as a service, providing that your microservices are PaaS friendly. Each new microservices will use resources. Cumulative resource usage may outweigh the benefits of the architecture if you really exceed the number of microservices that your DevOps organization, process, and tooling can handle. Therefore, it is better to be on the side of creating larger microservices and only split them when they end up containing parts with conflicting demands for scaling, lifecycle, or data. So the main point being emphasized here is don't create too many microservices such that your DevOps is not able to handle them. You have to have a good balance. Making them too small will transfer complexity away from the microservices and into the service integration task. And definitely don't share microservices between systems.